Good morning all. Today we will start our discussion regarding the graphing of a function from very basic level onwards. That is what actually mean by the scale point and construction of Cartesian space, and accordingly then we will go for discussing how to draw a particular graph. See, when we hear about a particular graph, the picture which come into our mind, which will be some drawings on graph paper, especially if you know from our school days, is that graph or something else, or it is one among the bunch of graph? See, the graph have different meaning in different discipline. It depending upon who use the graph and for what purpose they are using the graph. In algebra and calculus, see, the graph is visual device that describe the relationship between two or more variables. Put in other words, see, it is simply plotting the function into a Cartesian space. So this will be a new term, that is a Cartesian space. So of course the question will arise, what actually mean by a Cartesian space? See, a Cartesian space is a grid line that is made from two number scales. It's also known as Cartesian space is also known as it is a Cartesian coordinate system. And it is so called Cartesian space, which is honor of René Descartes, the great French mathematician of 17th century, who actually solved the puzzle of describing the position of a point on a plane by making use of latitude and longitude on the idea of geometry. So actually the graph provide a way to describe a position of a point in a plane using two perpendicular axes, usually labeled as it is a x-axis and y-axis. It is actually a powerful framework especially used for representing geometric shapes, analyzing functions, solving equations, understanding spatial relationship in two-dimensional space. So this is the Cartesian space. So the next we are going to develop the Cartesian space. For that in order to create a Cartesian space, of course a Cartesian or Cartesian coordinate system, we have to establish two perpendicular axes defining the unit of measurement, which is generally known as a number scale. So a number scale is a one-dimensional representation, or it is a line on which the distance from a point are numbered in equal units, positively in one direction and negatively on the other direction. So positive direction, it is typically indicated on the one side of the origin, while the negative side represent on the opposite side. See here, the reference point which these positive and negative values are numbered is called, which is origin, which is the origin on the scale. And this origin is often designated as 0. From the origin we are starting, so we are putting 0 on that particular scale. And the positive values are assigned to the point on the positive direction, and the negative values are assigned to the point on the negative direction. And the number scales are two types. One is horizontal number scale and another one is vertical number scale. See, the horizontal number scale is a line, or we can also say that it is an axis representing the number values. We have a different number values are here, which is oriented in a horizontal manner. This is representing in a horizontally. So the origin here, it is located in the middle of the line, and the positive values extend to one side while negative values are extended to the another side. And this line is commonly used to express the x-axis in the Cartesian coordinate system. So similar to the horizontal number scale, we have a vertical number scale as well. And this vertical number scale, it is the line or axis which is representing the number values which are oriented. See, it is oriented vertically. So the origin here also it is located in the middle or the center of the vertical line, and this is known as origin, and the positive values are extended downward, and it is in this particular value positive values are extended upward and the negative values are extended downward. And it is generally used in the Cartesian coordinate system in order to denote y-axis. So this is the vertical number scale and horizontal number scale. Now suppose if we go for combining these two number scales, that is when horizontal number scale and vertical number scales are showing here. See, it will be, this is the vertical number scale showing here where 0 is showing the origin, and we have a horizontal number scale which is also positively and negatively pointed, and here we have a 0 origin. So here horizontal number scale and vertical number scale which are perpendicularly to each other in such a way that their 0 point is at this particular origin, that is 0 point is coincide. So in that case the resulting structure is known as, this particular structure is generally known as, it is a Cartesian coordinate system, or it is a Cartesian plane. It is a Cartesian coordinate system. Now see, we can draw different models of perpendicular. Maybe this can be drawn in this model, we can be drawn like this, or we can also draw this particular model. So here we can draw this perpendicular in a different way. See, it is entirely depending upon how you have made the perpendicular lines. But here we are only stick on the graph which is shown here, that is in this particular model, and in this Cartesian space the horizontal number scale is usually called, it is the x-axis, and the vertical number scale is generally known as, it is the y-axis. We have x-axis and y-axis, and as the number scale, the origin of the graph where two scales are intersecting or crossing each other. So the point where the axes are intersecting, typically it is the origin, which is 0 and 0, which means that 0, 0 coordinate. That means 0 of the x and 0 of the y. So scaling on two coordinate axes is often the same, but it is not necessary. It is entirely depending upon the need and who is actually going to draw the particular graph. Now see, we are going to discuss about the quadrant. The coordinate axes separate the plane into 4 parts. We have 4 parts, 1, 2, 3, 4 parts, or it is generally known as, it is a quadrant, which are numbered in a counterclockwise. See, the quadrant 1, this is the quadrant 1, which is the northeast quadrant, or we can say that it is the upper right portion on the Cartesian space, and here both x and y coordinate, x values and y values are positive. So this is the space, that's why it is used in the all discipline of the graphical analysis. Mostly we are using only this much, positive value of x part and the positive value of the y part only. And thus the point will be formed a plus and plus, which means the positive value of both x and positive value of y. See, the second quadrant, see, it is the quadrant 2, which is the northwest quadrant, or it is also known as, it is upper left corner or upper left portion of the Cartesian space. See, where x-axis is negative. This is x-axis is the negative, but at the same time y-axis is having positive values. So thus the point will be formed a negative plus. A negative plus, negative is the coordinate point of the x-axis, and plus is the showing the y elements. So it is the negative x values and positive y values in the second quadrant. The third quadrant, see, it is the take place in the southwest quadrant, or it is the lower left portion of the Cartesian space. And here both x and y values are negative. See, this is the x-axis, this is negative values, and y-axis which is also negative values. The point will be form a negative negative. Both are negative, that is negative value of both x and y. And the last quadrant, that is quadrant 4, which take place in the southeast quadrant, or it is the lower right portion of the Cartesian space, see where x values are positive. However, the y values are negative. So thus the point will be plus minus. It form a plus minus. That means positive value of x and negative value of y. So thus this quadrant system describes the location of a point in a coordinate system, and the sign of coordinate, that means whether it is positive or negative, indicates in which quadrant the point is located. Now the coordinate points, as we are already discussed earlier, see Cartesian space is explaining a systematic way to describe a position on the point in a plane. So every point on the Cartesian space correspond to a unique order of pairs, that is x and y values. And these unique ordered pair are numbered, see it is x and y. These are the unique ordered pairs of number, for example x and y values, which are called, it is the coordinate points. It is coordinate of the points. And this is the ordered because the order shows its distance from the axis with appropriate sign is also attached. See here, one coordinate point system is shown here. If we have a stick on this particular point, that is unique ordered pair of number which is marked here x and y, which is called the coordinates of this particular point. And here see the first number of the coordinate, that means here x, which is the coordinate point which is called first coordinate, or it is the x coordinate, or we can also say that it is the abscissa of the point. And the second number is called, it is the second coordinate or y coordinate, or it is the ordinate, that is y, this one. Okay. Now see, suppose we have a point on a Cartesian space. We have a point here, that is point A, and we want to describe the position of point A. How will describe the point A here? See, we will explain the point A in such a way that we will drop a vertical straight line from the point of A to the x-axis and mark the value here. See the x coordinate here. Thus here in our example we get 5 as the x coordinate. X coordinate is the 5. Similarly, see from at the point A we have to draw the y coordinate, which is identified by drawing a horizontal line, as I have already drawn here, from the point of A to the y axis. So the point that cut the y axis will be the value of y coordinate. So here it is we have 4 as the y coordinate to our point A. So thus the coordinate of the point A at this particular point, what are the various coordinate? That is the 5 and 4, and expressed as the point 5 and 4. First we will write the x value, then we will write the y value. So here by convention the first number inside the bracket, that is always x coordinate, and the second number is always a y coordinate. See, one of the important characteristics of a Cartesian coordinate system is that each point in this space is unique and has a distinct set of coordinate, which means that, see, there is a one-to-one correspondence between the point in the Cartesian space and their coordinate. No two distinct points share the same set of coordinate. Therefore, any change in the coordinate corresponds to a specific change in this position of the point. So if the point change, then uniqueness is also changed. That is one of the important characteristics of a Cartesian system. Okay. Now we are going to draw the graph from the input-output table. See, drawing a graph from the input-output table, which actually involves plotting the point based upon given input-output pairs on a particular coordinate system or particular Cartesian plane. Look at the input-output table and understand how it related to the coordinate planes. For each input correspond to x values, we have a corresponding y value as well. And then what we want to do, we have to identify x value or input value and y value, that is output value, for the each pairs of input and output value. So we will have a input output pairs, and these will be generally treated as a coordinate points, and we can directly go for plotting that particular coordinates on a graph. We can explain the same thing by using an example. See, we have a given input output table, and we were asked to graph the given input output table. See, how do we plot it? We have given the x values, that is -2, -1, 0, 1, 2, and the f of x is equal to -9, -2, -1, 0 and 7. So if the tabulated x and y values are given in this model, then what we want to do, we will transform this particular input output table by inserting one more column, see, that is representing the coordinate of the point, that is the coordinate x and f of x, and f of x. So what we are doing here, we are simply creating a pair. So here -2, -9, which will become a one pair, -1, -2, which will become another pair, 0, -1, which is also another pair, 1, 0 and 2, 7 are the remaining pairs. So here these pairs are nothing but it is the coordinates of the point. Once we get this input output table and transforming into the coordinate points, then we can directly graph this particular points into the graph paper or Cartesian plane, and we can draw a smooth curve by connecting these points. Let's see how we will do it. See, we have a Cartesian space is given here. First we will draw the Cartesian space. See, this is the Cartesian space. How many quadrants we have in the Cartesian space? See, we have a Cartesian space with the 4 quadrant, quadrant 1, 2, 3, 4. We are already discussed. Why we have a 4 quadrant here? Because in our example we have both elements as minus b, -2 and -9, and also plus values, minus values, both are remaining here. So because of that, see, we have a both positive and negative value for x and y. See, conventionally we will draw the Cartesian space on a one extra unit in the upper limit axis and negative extreme values, and accordingly we are extending into some higher level. And see here, first we will go for plotting the first coordinate, that is -2, -9. And how we will plot it that? See, we put a dot mark on the x coordinate. See, -2, it will be here, it is -2 on the x axis, and then -9 on the y axis. So it will be the particular point. Then similarly we can plot the second point. See, -1, -2, which will be -1 here, x axis, and -2 from here. So it will be point, this dot mark is given here. Third one, 0 and -1. So at the 0 x value we have a -1 y value. Similarly 1 and 0, see here, this will be 1 x and 0 y. Then 2 and 7, which is here the 2 of x and y, 7. Now by connecting these points, see, we will get a smooth curve, see, shown just like this. We will have a smooth curve just like shown here. See, this is the way we can draw a particular graph. We can also draw, see, there is no way of guarantee that the curve we pass through the plotted point is actual graph of the function. See, it can take n number of ways we can draw, and there are only some other possible format of the curve. See, then how we could choose the correct graph from the large possibilities? See, for that we have to need more point which should be plotted in between these given plots. With more points, we will be in a position to accurately draw the particular curve in an exactly proper manner. Okay. Now, we have a distance formula. We have a distance formula that is one of the important and immediate benefit that arising from using a Cartesian coordinate system, which is that distance between any two points. See the distance between any 2 points in the plane which may be expressed in the term of coordinate points. Distance here means that, see, it is the length of straight line segment that connect the 2 points in the plane. So we have in the Cartesian plane, if we have 2 points is given and we want to find out the distance between 2 given points, then the distance between any 2 points in the Cartesian plane can be calculated using a distance formula which is actually derived from famous Pythagoras theorem, which we are already studied from our school level. See the distance formula which provides a straightforward way to find the length of a straight line segment which is connecting between 2 points without the need of any type of visualization. Suppose, for example, we have 2 points, point A and point B, and point A we have two coordinates, coordinate 1 having x1 and y1, that is at point A, and at point B we have x2 and y2, which are the any 2 points in the plane. And we want to find out the distance between A and B. So this distance can be calculated by using the formula, that is d is equal to, it is the square root of the sum of the squares of differences in the x coordinate, that is x minus x1 square plus the y coordinate, which is equal to y minus y1 square. So the distance formula, or we can calculate the distance between 2 points by using this particular formula, that is under root of x2 minus x1 whole square plus y2 minus y2 whole square. So by using this particular formula we can find the distance between 2 points. Let us consider one example. See, we have a 2 point A have a coordinate of x1, y1, which is having the point, the 2 and 4. That means x1 is equal to 2 and y1 is equal to 4, and point B, that is x2, y2, which is 4 and 5. That means x2 is equal to 4 and y2 is equal to 5. And what we want to do? We find the distance between A and B. So of course, in order to find out the distance between A and B, we can use the formula which is given here. So the distance formula here under root, x2 minus x1 whole square plus y2 minus y1 whole square. So we know what is x1, x2, y1, y2. See, x1 here it is 2, y1 is 4, x2 is equal to 4 and y2 is equal to 5. And just we want to put all these values into this given formula, it will become d is equal to x2 is equal to 4 minus x1 2 whole square plus y2 minus y1, that is 5 minus y2 here it is 5, y2 minus 4 whole square. See here, if you go for solving it, then d is equal to 4 minus 2, which is equal to 2 square, plus 5 minus 4 square, which is 1 square, which is equal to 2 square is equal to 4 and 1 square is equal to 1, the under root of 4 plus 1, which is equal to under root of 5. And what actually this root 5 showing? See, this is the distance between the point A and point B, which is equal to, it is root 5 units. It is root 5, not 55. It is root 5 units. So we can find out the distance between the 2 points, especially on the straight line, by using this particular formula. So let me conclude here. In this lecture, actually we discussed the concept of Cartesian coordinate system or Cartesian space, and we also discussed what are the various procedures to draw a particular graph, and I hope it is clear to you. In the next lecture we will discuss how to draw the graph of a function, and actually what actually mean by the concept of slope, how to find the slope, especially from the given 2 coordinate points. All these things will be discussed in the next class, and we will see in the next class. Thank you.